All right, folks, welcome. Thank you for joining. We are back with our CCNA Journey. And this is, of course, most privy to our Slack members, right, that are chasing after their CCNA or going after their CCNP. Because, of course, a lot of fundamentals come from the CCNA. So it's always a good refresher. And, of course, I like to do my best job, like I always like to say, explaining, at a high level, certain topics, technology, and sometimes go low level so you guys can actually understand it and see what it looks like, right? So we're moving on to chapter 18, right? Because last session we had, which was like a month and a half ago, it was talking about, certain things in IP routing, right? We talked about how it looks in depth. We did a lab, we actually saw how things work from a layer 3 perspective, right? But the last piece that we need to go over, right, with anything is troubleshooting, right? How do we troubleshoot IPv4, right? And how do we troubleshoot routing, right? So that's what we're going to talk about today, okay? So let's go ahead and jump in, right? So like I told you guys, of course, I'm always going to do this reminder, right? My favorite thing in the world, right, as it regards to network engineering, the CCNA, anything Cisco, is the OSI networking model, right? And the TCP/IP network stack, right? And of course, this session we are talking about layer 3 in both the OSI model and of course TCP/IP network stack, right? They're both layer 3. So let's go ahead and dive in, right? So we all know what a ping is, right? Even before the CCNA, right? Some folks maybe worked help desk, right? And maybe you're learning from your CompTIA, right? Or you maybe learned on the job, right? How to use the ping command, right? What's the benefits, right? To confirm reachability, right? How to do layer 3, right? And so on, right? Helps you get the job done and how to escalate it would happen, right? But what's the problem? What's the problem with using the ping command, right? So let me go ahead and brighten your world real quick, right? So somebody reaches out to Antoine, right? Antoine being the network operations center engineer, right? And so they say, hey man, can you look into this network issue, right? And it's an end user calling him, like, have him look into this network issue. Antoine says, oh, fine, yeah, I can go ahead and look into it, right? So what Antoine does, right? And I'm using this diagram. Antoine, he goes ahead and SSH, right, into router 1, right? And he goes ahead and issues a ping to the destination, right? Right? And he sees, oh, it's working, right? And he says, okay, I issued a ping, it's working, right? But there's two questions, right, that comes to Antoine's mind, right? What is the result, right, of the output of the command rule out has a possible reason for the problem of why the guy is reaching out? And also, what does it rule out? As in, is there still a problem? Is there still a root cause, right? So he's talking to the client further, right? And they give them another destination address, right? And he issues another ping, right, from router 1, right, to another address. It fails. We're getting closer, right? And he sees that he's getting failures, right? And it tells him a few things, but he's asked himself, okay, what is this telling me about, reachability would happen, right? What parts of routing, right, may still be the problem, right? What parts would Antoine, being the engineer, see as not the problem, right? And so the beautiful thing about the ping command, right? It gives us, it's like it's a switchblade, right? It's a all over tool that you can use to, maybe crack open a can, right, of beans, right? Or maybe to turn a screw, right? The ping command can do a lot of things, right? But when it works, right? Whenever the ping command works, it confirms a lot of things about IP routing, right? Rules out some problems as well, right? But when it fails, right, it helps narrow down, right, some inter-network issues, but it doesn't tell us the root cause, okay? And so in today's session, right, we're going to talk about how, how using the ping command can't be an end all be all, but we have to go ahead and combine what we're learning, right, along with our investigative skills to troubleshoot IPv4 routing. Okay, so let's go ahead and keep going. So let's talk about this network, right? So in simple, right, ping, it uses ICMP, right? And how it works is it sends an echo request, right? And the protocol says, that destination is supposed to send an echo reply back, okay? And so as you see, PCA, right? 172.16.1.51, that's sitting behind R1, right? It's gonna go ahead and send that ping over the wire, over the internet, over the WAN, get to R2, get to the destination, and reach 172.16.2.101, right? And it's gonna get it, it's gonna say, hi, I got a ping. I'm gonna go ahead and send it back, right? To, and my packet's going to be an echo reply. Simple enough, right? That's the basic concept of a ping, right? It's testing reachability via IPv4, okay? Right, and we're still in layer 3 now, okay? Not going nowhere. So let's keep going, right? And so Tuan being the engineer, right? This is what he's looking for, right? From his PC, he's testing, right? He's testing the pings, and this is what his outputs needs to be, right? It's giving him that he's getting package, right? You see that 64 bytes from, of course, the destination, right? He's getting things back, right? It's telling him the sequence number, is telling him the time to live, which of course TTL, and of course the time it took to get back to him, right? Simple ping, right? And it's telling us, of course, I can reach this destination, right? So that's great. That's great, right? But going back to our original theory, what if the network is longer, right? And what if it was not working, right? How would Antoine get to the root of the issue, right? And this is where you have to definitely use certain strategies, right, to get the results that you require using commands like a ping or a trace route, et cetera, et cetera. Okay, so right, if we look at this, right, if you look at my screenshot here, and again, all of this, all of my screenshots, it's credit to Cisco Press, right? Everybody that wrote the CCNA 200-301 Value 1, right? So all of it is screenshots from there, credit to them. But if we go ahead and take a look at this, right? Here's one strategy, right, for troubleshooting, right? Is testing longer routes near the source of the problem, right? So let's switch up the topology, okay? Let's say, right, maybe Antoine is the network engineer for a campus layout, right? Different buildings, it's split up via layer 3 boundaries, right? It has routers all between, right? And of course, he gets the issue, right? Similar to the previous picture, right? Similar to the previous picture, right? And he's testing, right? He's testing reachability, right? And what he's looking for is, right, logging into, one of the routers, right? He's looking to see if he has reachability. Boom, excellent, I'm getting pings. Pings are working, right? But looking at this, right, we see that, that his router, right, can go ahead and send those echo request messages, right? Because again, it's issuing a ping sends those echo requests, right? It's sending out that echo request from the outgoing interface of R1, right? And it's going out, right? Because by default, right? If it doesn't exist in the routing table, it's going to go ahead and send it out using, of course, default route. It's going to go ahead and send that to the next hop, right? It sends it, it can go ahead and reach it, and it works, right? He can go ahead and reach it. So this is how it looks, right? And so this is what Antoine is doing, right? He's testing longer routes near the source of the problem, right? He's starting at his router, but going with inside the network, right? Behind R2 to go ahead and test it, right? And so he's thinking about the, in a certain direction, right? The flow of traffic of I need to get as close to the problem as possible, right? And so if he tests the ping first and it fails, what do you think he can do next, right? He can go one step back and start at the inside interface of R2 and start going from there, right? And this is one strategy, of course, what is called testing longer routes near the source of the problem, to go ahead and do a process of elimination, right, of testing reachability, right? This is one strategy, because if we're just using pings, right, and just pinging a destination, that's not going to tell Antoine anything, right? If he just went with that, he would just give up and say, hey, I can't reach it. I don't know what to do next. He would use his strategies and investigative skills to see, let me ping something that's still close to the source of the problem and investigate from there. Okay, so, right, so if we're looking, right, we're still talking about the topology now, right? If we're seeing, how his, we're going to say his campus layout is set up, right? How these routes work, right? They're different, right? You have our connected routes, which of course are connected directly, right? R1 and R2, right? R2 also have connected routes, right, to its inside network, right? R1, whether it be static or dynamic, knows about how to get to, of course, 172.16.2.0, right? Antoine is issuing those pings. It should work, right? It should work. Everything should work, right? But one key thing, again, using strategies, right, is that him testing, right, longer routes near the source of the problem, he's, of course, is going to check his configuration as well. He's going to check, like I tell you guys, my favorite thing, he's going to check layer one. He's going to make sure that the interfaces, right, of course, on his router, right, is in an up state. He's going to do that on R2 as well. He's also going to check on the switch, right? But remember, I want you to keep reading the title of this, testing longer routes near the source of the problem, right? What's the next thing that's next to the destination, right? It's behind switch 2, right? Antoine put a management, he puts a management IP so he can reach it in SSH into switches on his network. He needs to get as close to the problem as possible. So he's going to go ahead. Maybe he can't reach the PC. He knows the PC is hanging off a switch 2. He's going to go ahead and SSH in there and check layer 1 and layer 2. Because him checking, right? Him checking R1 and R2's interfaces, it's a good strategy. It's a good process, right? But how much more efficient, right, and less time consuming would it be if he went ahead and tried to, of course, ping the switch, right, and SSH to it and check layer 1 and layer 2 for that connection, right? He is testing longer routes near the source of the problem to rule things out. So he's checking, of course, for layer 1, layer 2 to the up state, right? He's checking for port security, right? We're going to talk about that because that's in the next book, right? In value 2, right? He's checking also for spanning tree. He's checking layer 1 and layer 2, right? He's making sure that has nothing to do with the issue because, of course, how packets flow, they have to be de-encapsulated, right? But before they're de-encapsulated, to go ahead and look at layer 3 and look at the higher layers, it has to go through layer 1 and layer 2. If layer 1 and layer 2 is not available, layer 3 is not going to be available. So that's when those failed pings come along, right? And so Antoine is doing his best job as an engineer to check these things. So this is one strategy that you always want to do, right? Is getting as close to the source of the problem as possible and doing the process of elimination there, okay? So, of course, right, and you guys are gonna learn about this later, right? There is a thing that also can be a part of the issues, which are ACLs, which is access control list, right? We haven't got to that topic yet. We will soon, right? But Antoine can check that as well, right? Maybe he goes ahead and he checks, hey, everything looks good on the switch. Let me check the ACLs on both, R2, which is maybe in building 2, right? And he's checking maybe ACLs on building 1. He can check that as well. But again, switch 2 is operating at layer 2, right? So that if he confirms layer 1 and layer 2 is fine connecting to that device, Antoine is again going to test longer routes near the source of the problem. What's closest, right? What's closest to, PCB? It's R2. So Antoine is going to say, okay, I did the process of elimination, right? Check layer 1, layer 2 on the switch. Now I'm going to go ahead and go to the layer 3 boundary, which is R2, and check if they're, layer 1 to layer 2, but then go to layer 3 and check if there are ACLs, right? Configured if anything inbound and outbound, right, are set or blocking my access to this subnet, right? And so, he's going to check a few things, right? He's going to check if ping is stopped, right? A couple of things in ACLs that I'm not going to get too in depth because we're going to have our session about that, right? But this is a few things that he's looking for because, again, if it's being blocked by the ACL, right, those packets are discarded for that subnet, right? Or maybe for that host, right? Because, of course, he can reach switch 2. We're just talking about this diagram. So, but maybe there's an ACL, host-based ACL, just for that host. Maybe somebody made a mistake. These are things that you as an engineer, you as a CCNA, have to put in consideration and add to your strategy, right? It's not just about putting in commands. It's about being investigative and finding out what is actually configured, right? So I need to get to the source of the problem as possible, okay? So, right? So let's say, right, pings are working, right? Pings are working to be. They're getting there, they're all working, and this is a whole new diagram, right? And we are, we are looking at this and we're saying, hey, R2, right, is connected to B, right? And a couple of other things that Antoine can do, right? He verifies, okay, so, there's no ACLs blocking it, right? What can he check as well? Again, we're all the way on chapter 17. So we learned about layer 2. We learned about what a MAC address table is. We learned about what a ARP table is, an address resolution protocol table, right? Address resolution table, right? That maps IP addresses to MAC addresses, right? On layer 3 devices, like a router. What Antoine can do, right, is use the strategy of a ping, of course, to the source of the problem, and then checking these tables to see, does R2 know about host B, right? Does it know what its IP address is? Does it know about its MAC address? Antoine can, the engineer, Antoine, can actually go into the switch, look at the table, right? And say, does it have it in its, MAC address table? Can R2 reach it? If it's successful because of this. A lot of strategies we can use and bunch together, right? To go ahead and find the root cause of the issue, right? It's not just using pings, okay? So again, another strategy, you can read about this, of course, in this chapter, right, in chapter 18, and learn more about it. It gives you awesome strategies. I actually used it, while working at, the Technical Assistance Center, right, for an organization I will not mention, but it works, right? But you have to combine strategies together to get to a resolution, right? So, right, couple of things, right, that we can go ahead and put together is, of course, is, give me 1 second, sorry about that, guys. Right, is we can go ahead and, test things with certain, certain commands and certain sides of a network, right? So with a layer 3 boundary, right, we have maybe a local area network and we have a wide area network, right? As you can see, looking at this diagram, right, we have a local area network, right? How would Antoine, right? How would Antoine, the network operations center engineer, how would he go ahead and test, right, his neighbors within a local area network that he has reachability, right? you can go ahead and issue a regular ping. You can say, hey, ping whatever my destination is, right? 172.16.1.51, right? Boom, it works. Excellent. I can reach it, all right? You know what I mean? So real standard, real easy, right? This is how it looks, testing reachability, right? Within hosts within the same network, right? Within the same local area, okay? Real simple, right? So couple of things, right, that it confirms whenever we're doing standard pings, right, within a local area network, right, is it can rule out some of the following, right? An IP addressing problem, right? Maybe I can't reach something because maybe the IP address is statically configured. It also can rule out, you know, we can rule out some DHCP problems, right? We can see maybe, I can't reach something, maybe because a host doesn't have an IP address. And I know, right? You know, Antoine knows, being the engineer, that he has DHCP configured. Maybe this host does not have DHCP configured here. So we need to go ahead and, you know, see what's going on and check that configuration, right? Maybe there's a switch in the middle, right? And it's multiple switches in the middle, right, that the engineer has configured. And maybe it's on certain VLANs, right? We segmented our network, our local area network, into VLANs, right? But with the connection between VLANs, right, the inter VLAN connection, right, maybe there's an issue at layer 2 with trunking, right, passing multiple VLANs over one link, over one pipe. Maybe it's not working. So that's one thing we can look to as well, right? As far as testing, you know, reachability to you know, different hosts and our quote unquote neighbors with the standard ping. Those are some things that we can go ahead and rule out has potential issues. And also, last but not least, LAN issues. We can go ahead and say, a wide variety of issues could exist. And I'm reading this word for word. With the layer 2 switches, preventing any frames from flowing between host A and the router, right? If it's working, right, we're good. If it's not working, we need to go ahead and check layer 2, right? That's what we went through, right? So a couple of things, if it's working, we can rule out. A couple of things, if it's not working, right, we see in this list can be potential root causes of the issue, okay? Now, let's talk about an extended ping, right? And I learned about this roughly, roughly 4 or 5 years ago. Break command, right? And this is a key topic for your exam, so you're probably going to have to remember it, right? So please pay attention. I'm going to read it word for word, right? If a standard ping works, right? Because we're talking about problem isolation, right? If a standard ping of a local area network host works, but an extended ping of the same local area network host fails, the problem likely relates somehow to the host default router setting, right? Let's talk about what that means, right? So if I have my PC, PCA, and the engineer has his PC, PCB, we're on the same local area network, right? He can reach me because we have configured the same IP address, right? Right? But he's trying to do an extended ping. An extended ping is a little bit more extensive, right? It's maybe going to reach out to the first router to go ahead and send that. It's not working because maybe I have the wrong router, the default router set, right, on my host, right? Couple of things, right? And again, the standard and extended pings have different effects, right? So let's go ahead and take a look how that looks, right? So the standard ping, right? It's going to go ahead and test, right? It's going to test, you know, reachability, of course, layer 3, but it does a few things. And of course, we can take a look at this, right? It's going to use the source, but I'm going to set it as maybe the outside interface, right? maybe I'm going to do that, right? Maybe I'm going to check that. And that's the great thing about using the extended ping command, is that you can say, use different inputs of what you want your destination to be, how many pings you want to set, et cetera, et cetera. And maybe, right, I have the wrong router set, right? The wrong default router set. I can't reach R1's outside interface because I configured who my default router is wrong. So there's an ARP coming from my PC saying, hey, who is, 172.16.4.1? And I'm screaming that on my network, right? But it's not getting to my default router, which is 172.16.1.1, right? Because it's another subnet, right? And so me not having it correctly set can make the extended ping fail, right? But if I have it correctly set, host A is going to go ahead, of course, do the same thing, right? Do an ARP and say, hey, who's .4.1 outside interface? R1 is going to respond, hey, here's the MAC address that's associated with it, IP address, go ahead and send it. So then, of course, that request and reply is going to go ahead and go through. Okay. So with that being said, we are going to end there, right? And of course, the next session, because of course there's multiple sessions, and I want to make sure I don't go too fast. There's multiple sessions that we're going to have to talk about this, right? The next session, we're going to go ahead and have a lab, and I can show you what a ping looks like, a standard ping, and of course, the extended ping looks like, all right? Well, you guys have a great night, and I will see you in the next session.